Okay, this is a quick video on how to determine the polarity of a molecule. There are two vital pieces of information that you must have in order to do this. Number one is bond polarity. Okay, so bond polarity, this would be like, is this a, non-polar covalent bond, polar covalent, and then of course ionic, but not really worried about that one right this second. So pretty much the only time you can assume nonpolar covalent is when they are identical atoms, or if it's a carbon-hydrogen bond, because their electronegativity difference is so small it's considered nonpolar covalent. So pretty much every other bond is going to be a type of polar bond. So the second thing you need is the geometry. Why do we care about the geometry? Because shapes, if they are symmetrical, can actually cause the dipoles generated by the polar bonds to cancel. So let's do a couple of quick examples. Alright, so CH4, better known as methane, versus CH3Cl. If we draw the Lewis structure for these, we will see that they both have tetrahedral geometry. Okay, so they're the same shape. This is one of the symmetrical shapes. And I gave those in my class a list of the symmetrical shapes. So, in a symmetrical shape, if you've got polar bonds, they cancel. Now this one has all nonpolar bonds. So, even if you thought they were polar bonds, it's going to cancel out. So this is a nonpolar molecule. In order to have a polar molecule, you must have polar bonds. So, hey look, there we have a polar bond. Okay, so even though this particular one is symmetrical, the dipoles don't cancel because they're not equal. So this one is polar. Okay, another example. NH3. Alright, draw the structure for that real quick. Okay, so all those dipoles are identical. However, this is not a symmetrical molecule. This one is trigonal pyramidal. And therefore, the dipoles do not cancel. Because of asymmetrical geometry. So we've got identical dipoles, but the arrangement does not allow them to cancel out. Okay? So that's pretty much it in a nutshell. If you've got polar bonds and an asymmetrical shape, it's going to be polar. If you've got polar bonds that are all identical and a symmetrical shape, then it's going to be nonpolar. And if you have nothing but nonpolar bonds, because they're either identical atoms or the carbon-hydrogen, then is a nonpolar molecule. Hopefully that helps. Thank you and good night.